It's an interesting question about the multi-sector nature of this business. Sometimes the federal government is in the lead and creates a new area. The computer itself was created by the federal government. The telegraph was created under federal support that wouldn't have happened otherwise. The internet was created under federal support. So in all these cases, there was no industry. The government lent its hand and its money to a green field, and great results happened. Big data is a little bit different. If you look at the Googles and the Amazons, et cetera, of the world, we see an awful lot of big data development that has already occurred in the private sector. So we're trying to articulate what is already known from the private sector, what developments are going on, where would federal research support help propel things forward more rapidly than they might be propelled otherwise.
Hybrid clouds are clearly of interest. So if you've got, for example, a commerce application that you're running in your private cloud, and if your the volume of requests that are coming in, especially let's say in the Thanksgiving to December timeframe, goes up, you want to be able to spill over from your private cloud onto the public cloud. There, it makes sense to do this to develop what you're doing based on standards. So there was a question that somebody asked about, what standard should we support as we do this? And my pointer there is that the largest standards effort that we've gone around is the one that we're supporting with OpenStack. Right? And so the OpenStack APIs are the ones to build to when you try to flow from your enterprise onto a public cloud.
I think now, actually, cloud computing seems to be at the same place that parallel computing was maybe 15 or 20 years ago, where there were no standards. And what happened was a bunch of people, academics and people from government labs and people from industry got together and decided this was not a sustainable future, that it was going to impede progress from the user side. And so I think clouds are actually at almost at that same point where it's time to actually seriously think about standards so that clouds can become that users can interoperate across different cloud providers. And that's up. There has to be, again, the business model there. There's an interesting question now because cloud providers are trying to make money, right? It's not just It's not just government funding or whatever.
A lot of the projects that I have done with businesses have been issues where they've had things arise that they would like to have some academic insight on, and I've been very lucky because some of those projects build off of each other. So for example, if you work on a project at American Express, some of the things that you learn, you discover are going on at Intel, and there are perhaps some people there you can work with to develop some of these things. So I think that there's R&D going on in these organizations, and I heard someone today say that they really felt businesses were in a lot of ways ahead of the academic institutions in the broader sense of much of the, say for example, big data research. I found that to be true, but I think the other piece of advice that was very relevant that I heard today was if you have a niche or you have areas where you're building expertise, then you can be a go-to person to kind of talk to and bounce some of these ideas off of. And the combination of services, computing, and the analytics and big data for me has been that sweet spot.
I'm told that most of the big companies are working on semantics in the back room, knowing that the time will come when they've pushed keyword technology to the limit, and they'll need to move on to key sentence and concept sentence technologies, like is the way I would describe the semantic technology. It requires the development of vocabularies, controlled vocabularies, sometimes called ontologies to mystify the public. I think the vocabulary horizon is still discipline focused. In my interests of science, I wish that every science would undertake a project to develop the vocabulary and the controlled vocabulary, the concepts, the classes, that would make it feasible to study or to put scientific literature in that area into a standard knowledge-based format.
the cloud OE, the operating environment, and the cloud API economy that IBM is helping to build, along with others, is a clear differentiator in helping our customers to be able to build these applications in an agile, nimble fashion. So that's very interesting to me, because the large corporations have been pretty much shut out from much of the work that has gone on in putting up the applications that in social and mobile, big data, etc. And this enables them to do it. We need to standardize on the APIs. So I think that the OpenStack API, IBM is contributing significantly to that. We need to put in the knowledge that we have based on managing a large number of outsourcing customers. We need to enrich the OpenStack API. That's one important thing.
The special issue about service computing really is that it is very people-oriented. Okay, it's different from traditional kind of research in computer science. Traditional kind are very system-oriented. But when we use the word service computing in this conference, this means that we take people into consideration. And as a result, different kind of people really have different needs. And the culture will play a role here. So people, customers in United States and the customers in Asia will be different customers. And as a result, the research and the methodology, as well as the initiative from the industry, will become different. And so there will be different niche in different kind of market in that way. And that's exciting.
There is significant benefit for our customers there, and we want to help them to achieve that. So that's what I'm really excited about.
To be truthful, I see it more as a continuum than as a huge step function. And I've watched the continuum develop for so many years now that I know that if it doesn't look much like progress on a year-to-year basis, it looks spectacular on a decade-to-decade basis. And so when you have a slightly longer time frame and see what has really happened, we can look back over the last 5 decades, and the changes in computing on a decade-to-decade basis are phantasmagorical.